This is Isabella. This is Fernandina. No, wait down. It's better. We need to one exit. Santa Cruz, Santiago, the island that we have right there. San Cristobal. For you have idea, no more. And one little rock. Darwin Wolf, exactly. Darwin and Wolf. Yes, okay. So, when we talk about geology, my friends, geology of Galapagos, because we are in one beautiful place with nice geological formation, is very important. Geology, when you come in diving in Galapagos, you need to understand about our currents and about the bathymetry and the water. Yes. Normally we recognize the works for underwater, like underwater topography. You know, it's normal the works to use topography underwater. But this is a wrong work that we use. In geology, they call bathymetry. All the perfil underwater, and topography from the sea level to up. You know, topography and underwater is bathymetry. You know. So the bathymetry around Galapagos is a huge platform here because all the islands coming from one hotspot, you know, the hotspot Fernandina. Galapagos is a hotspot. Hawaii is another hotspot. We have many in our planet, yes? Yellowstone is another hotspot. In South Africa, another hotspot. We have many, you know, New Zealand is another hotspot. So Galapagos come all the island here in the central and the south, coming from here, from the hotspot. One of the Jungle Island and the Mystic Island is Fernandina. We're going diving there next Friday. Yes, Fernandina, Isabella, Santiago, Santa Cruz, San Cristobal, Española, around here. And there we have, what's your name, my friend?
My name?
Sí.
Valentin.
Valentin. Valentin?
Sí.
Yeah. Valentin is Ecuador. You know, Valentin is Ecuador. And you, sir? Your name?
Gustavo.
Gustavo is Brazil. Yes? South America. Ecuador, Gustavo is Brazil. You know? And there South America is one tectonic plate. You know? It's a surface tectonic plate, or we call continental tectonic plate. So Pangea was the huge planet in our planet. Was a huge tectonic plate, Pangea. And many years, and everything changed in our planet. And the fracture of this tectonic plate called Pangea divided different tectonic plates around our planet. And now we have the oceanic tectonic plate called Pacific tectonic plate, which is strong in all the Pacific in the west. And we have around Galapagos and all this area in the south of Chile, in front to Peru and Chile, we have Nazca plate. Yes, Nazca plate, and in the north, you know, close to Darwin, we have another tectonic plate called Cocos plate, going to the Central America, you know. And this tectonic plate called South America, you know, this is a continental plate, is one of the stronger, like the Pacific tectonic plate that we have in the west. So these little tectonic plates are smaller and all the time are in constant movement because the Pacific tectonic plate press these small tectonic plates directly to the surface tectonic plate, which is South America. And the South America, one of the stronger in the surface, suck this tectonic plate underneath. Yes, so this tectonic plate called Nazca, we move to the South America, to the east and southeast, you know, because the Pacific tectonic plate press too much this tectonic plate Cocos and Galapagos. That's why we have Panama, you know, Panama. It's because all these tectonic plate goes there, and we press this tectonic plate in Ecuador and South America, you know, and we going underneath. So all these tectonic plate going underneath of South America. That's why we have Los Andes, many volcanoes around Colombia, Ecuador, Peru, Bolivia, and Chile. We have huge volcanoes there. Yes, because this subduction make a huge explosion, accumulate a lot of energy underneath, you know, the pressure of this material, you know, pressure and accumulate a lot of gases here, and in some events, these gases make earthquakes, break the crust, and poof, make eruption. And one volcano coming up here, like the hotspot, you know. And so the islands that we have here, why we put the big ones here? Because the huge volcanoes, the jungle volcanoes that we have in Galapagos, Isabella, and the hotspot Fernandina, one of the highest altitude here we have in Galapagos, yes, and are the biggest because they are young. And the way they go into the mainland, because the tectonic plate in the South America suck this tectonic plate here, you know, and we go in that direction. 3.5 millimeters, we displace to the southeast, to the east. So this island, probably, San Cristobal, disappear in the next years. We have many islands disappear in the ocean. So imagine, here is the sea level, the surface, and we have a huge mountain, like this island. And we move 3.5 millimeters per year in that way. So in million years, probably this island disappear. You know, we have Española here. It's, imagine Española is this guy, very flat, you know, no more than Española has 86 meters from the sea level. Probably Española was a huge mountain, huge volcano in the beginning when coming up here in the hotspot. The hotspot is the connection from the inner core to the surface. The inner core accumulate a lot of energy there, and liquid magma, gases and minerals. You know, break the crust in the ocean, make an explosion. In the beginning, the explosion is gases and ashes. Ashes mixed with the salt water in the ocean, make a capes, and solid but fragile, like this rock there, or the tuff formation that we have in front, or the pinnacle there. You know, make a capes, and another liquid magma coming up here because it's the hole there, you know, or lava tunnels, lava tubes, you know, all the material coming up here, one explosion like a huge mushroom, you know, mixed with the salt water in the ocean and make a little mountain. And in many eruption, many activity from this volcano, the island coming up here to the surface. Some explosion keep in the middle of the ocean and some coming up here to the ocean and make a huge island. That's happened with this island here. And in some islands, very high altitudes, you know, and displaced to the southeast, you know, and after disappear under the water in the ocean. Yes, that's why Galapagos, the biomass of marine life here is huge, because we have the connection, this platform called Galapagos and this tectonic plate with the mainland, you know, with South America and another countries there, and we have currents. Currents come from the north, you know, and hit these sea mounts that we have here. We have a sea mounts here. Imagine the sea mounts are here and the surface is here, 500 meters. And all these submarine current hit here and bring the stuff to the surface. And we call a flooring of plankton when we have upwellings. Upwellings of the Granville current from the west, upwellings from the Humboldt current. So the Humboldt current coming from the Antarctica along of Chile, Peru, and after find this carnivore that we call these sea mounts in the ocean and converge to Galapagos. And mix with another currents from the west, from the north, and make an explosion of light around here. Yes, very important information because we're going diving and we need to understand the bathymetry of our places here. It's not like the Caribbean long coral reef. It's easy to dive there. You know, here we're going to find current in different directions, maybe in only one direction, or maybe no current, but a little bit more there is another bathymetry, and the current you're going to feel in another way. Yes, and it's very important. And it's very important to understand about our geology when we understand about the formation of Galapagos. Wolf and Darwin, very important. This island in the central and in the south come from the hot spot from Fernandina, which is the directly connection to the surface from the inner core. Yes, but Darwin and Wolf not coming from this hot spot. Darwin and Wolf, Pinta, Marchena, and Genovesa, the islands that we have in the east, in that direction, we have San Cristobal in the south, coming from the hot spot, but Genovesa, Marchena, Pinta, Wolf, and Darwin in the north, they are coming from another formation. Imagine, this is the Cocos Plate, you know, you are the Cocos Plate, and we are Nazca, I'm Nazca Plate. Imagine the friction of this tectonic plate all the time. We keep warm, no? Yeah, you know? This friction of the tectonic plates, because we have the oceanic stronger, Pacific stronger current, push this tectonic plate directly to the mainland, and this friction accumulate a lot of energy underneath, you know? And this energy need to come into the surface because the chambers are not enough. And the material break the crust, and the fracture of these tectonic plates, because it's two tectonic plates and has a fracture, and here is the way this material coming up here. Gases, material, liquid magma. Boom!